Hello class, Miss Well. Today we have our lesson 4 on nonlinear regression. We are going to talk about what is a nonlinear regression. We also are going to introduce a coefficient of determination. We are not going to do nonlinear regression by pen and paper in this course, and we are only going to use technology or Google Sheets or a spreadsheet. And at the end of the lesson, I am going to show you how to use Google Sheets for nonlinear regression. But first of all, we want to define what is a nonlinear regression. Now, sometimes relationship or correlation between two variables are not linear, meaning that a line of best fit is not a right model for the data being presented, and in this case we have to do what is called a nonlinear regression, and that means we are going to find a curve of best fit for a set of data. I am going to start with an example for you to see what I mean, and then I'm going to tell you what kind of nonlinear regression is available to us through technology. Now, a group of physics students record the distance of a ball falling from the top of a 4-meter ledge. So they have collected the data presenting distance versus time. Now, all of you by now probably know that this is not going to be a linear relationship, and this is actually a quadratic relationship. So here is the data. Okay, so these dots here represent the scatter plot for our data, and as you can see, if we try to do any kind of line of best fit, a linear regression is not a good model for this data. But if we move from a linear regression into a quadratic regression, you can see that a curve of best fit will be a better model for this data. Now, what we are going to do, and I am going to show it to you at the end of the lesson, is we are going to use spreadsheets for our nonlinear regression, and we will try to find what is the best curve of best, the best equation of the curve of best fit. Now, your data can be in one of the regressions that you can do is actually exponential regression, which typically, if your data looks like this, and the equation given to you by the technology will be in the form of y equals a number times e to the exponent x. Now you have learned this irrational number e in calculus. It is similar to pi. It is a irrational number, and its name is Nepper's E. Now, most of the time, what is given to you as an exponential regression is in the form of y equals a e to the exponent x. You may sometimes have an option to get your exponential as a times b to the exponent x, where b is your base as a number. So this is the exponential regression. You can always have the linear regression, which is the line of best fit. You may have some data that can be represented by logarithmic regression. those of you who did advanced function in first semester, you know how the graph for logarithmic functions are going to look like. Now, you also have an option to have a polynomial regression, which means your curve of best fit is going to be in the form of ax to the exponent n plus an, then an minus 1, x to the exponent n minus 1, and so on and so forth. It's going to be in form of a polynomial. If your n is 2, meaning the highest degree of x is 2, you are doing a quadratic model, similar to what we did in the example. In the previous example was a quadratic model. And if your n is 3, the model that fits your data is going to be a cubic model, and so on and so forth. You can also have a power model, which your fit your curve of best fit is going to be in the form of ax to the exponent b. Now, you have to know that sometimes for a certain set of data, more than one nonlinear regression can provide a good fit for our data. Now the question is, how can we decide which one of these are the best model for our data? There is something which I'm going to show you how to look at it in the technology. There is something called coefficient of determination, or R squared, but please do not mix this with R, the correlation coefficient. This is R squared, which is called the coefficient of determination, and has nothing to do with correlation coefficient or lowercase or Pearson's R. Now, this number will help you figure out which type of regression is most appropriate for the data. This number always gives you a value between 0 and 1. The closer your model is to fitting the data, the better your regression. This number is going to be higher and closer to 1. For example, if it's 1, it's a perfect fit. The curve of best fit is going through all your data. And the closer it is to 0, it means that the model you have selected is not a good fit for your data. So what you are going to do is you are going to use technology to look at different curves of best fits and regressions, and based on the value of R squared and the context of your problem, you will decide which regression, nonlinear regression, best fits your data. Now let's go and figure out how we can use technology for nonlinear regression. We are now going to learn through an example how we can use Google Sheets and technology for nonlinear regression. I have a table of data here which has a growth of a bacterial culture, and by scanning it on different time intervals and recording the population in the bacteria. And what we want to do is, the first thing we want to do is we want to draw a scatter plot, and then we are going to look at different regression, non-linear and non-linear regression models for this data and figure out which one fits this data better, and then we are going to use that model to answer some questions and estimate some future growth for this data. So as we did before, we select our data, we go to insert, chart. Now, as you can see, this is a line chart. So in the setup, we go and change this into a scatter plot. I'm going to make it a little bit smaller here. Now, we want to do some regression and see which regression model fits the best for this data. It should be obvious to you just looking at the data model that this does not represent a linear model. So in order to do different regressions, we go to customize in the chart editor and we go to a series. And we are going to, like before when we did linear regression, we are going to check the trend line. I am going to change the color of the trend line to red, and I'm going to change the opacity to 100% so you can see our trend line better. The default here The default here is linear. Now I am going to ask you that whenever you do regression, I'm going to ask you to do two more things. First of all, we talked about this R squared in our lesson. Please don't mix it up with our Pearson's R. This is a totally different value here. This shows us how a specific regression fits our data. Now I think I've labeled the data. I'm gonna uncheck that. Okay. So first thing I want you to do is to check show R squared. And then also there is what we have cost label here. I want you to say use equation. So this is going to show us the line of best fit equation, and the R squared here is 0.875. And as you can see, this line of best fit is actually not a good representative of this data, and the closer the R squared is to 1, the better the regression model is for your data. So now you can go and try other regression. So we've done linear. Now I'm going to change it to exponential. As you can see, the R squared is 0.999, and this seems like the perfect model for this data. Of course, you should have guessed that the growth of bacteria is an exponential model. We will come back to this model again, but I want to show you other options here. You can have polynomial when the degree is 2, that means it's a quadratic model. It is 0.99, so it seems that it may seem like a good model, but the reason that this is not a good model is that you can see that it seems that it keeps going up, like it's reaching the vertex here and keeps going up. And we know that we started with initially with a lower number of bacteria. We cannot have our bacteria numbers going up. So sometimes when you are doing regression, it's not just looking at the R squared, you have to be able to recognize whether this model in the context of your data is meaningful or not. So please pay attention here. It seems that it's going up, and you can have more bacteria rather than less when you go towards like time 0 when you started the growth. Now we are going to try logarithmic. It's not a good model, 0.627. And we are also going to do power model, again, the R squared is lower, so it seems that the best model for us in this case is the exponential. So when your data is nonlinear, that's what I want you to do. I want you to try different nonlinear regression models and look at your R squared, and at the same time see if that model is meaningful in the context of your program. Now here, if you look at the equation here, it's 266 e to the exponent 0.304x. By now, you should have covered this in your calculus courses. E is an irrational number in mathematics, like the same way pi is, and it's called Nepper's E. So if you want to sort of go and search on it, or I'm sure your calculus teacher has already talked about it. Now, this seems to be the best fit here. So what I'm going to do is I am going to use this model to do some predictions. So for example, I'm going to close this now. I'm going to just keep this scatter plot here. This scatter plot has data from 1 hour to 10 hours. Let's say we want to see in 15 hours how many bacteria it's going to be in our culture. So here I am going to put my time, so which is 15. So I am going to extrapolate here using this non-linear regression, exponential regression equals 266. So I'm going to use the equation from here, 266. Now, for e to the exponent of something, you are going to use the built-in function exp, exponential. And here it's 0.304, so 0.304 times our x value. So as you can see here, in 15 hours, there is going to be 5,425 bacteria in the culture.